Previously, we looked at how to read data from files and make use of that data in TensorFlow. In this video, we'll take a closer look at data and its various representations. One approach to understanding tenses is by looking at the data that we make use of. We've already made use of tabular data in examples. We've seen how to import this type of data and how to convert it into a NumPy array. In previous exercises, we saw how data got converted into an area with rows and columns. That gives us a matrix. Let's go a bit further to where we defined our weights and biases. When the info you have can be represented in one column or row, that's called a 1D tensor. For example, if we would like to store rainfall data for one location over 1 year, this can be presented as a row of data with 365 entries. When the data you have requires rows and columns, you make use of a 2D tensor. This works with tabular data. It's also used with grayscale images. These are images with only one color channel, where each pixel ranges intensity from 0 to 255, with 0 being black, 255 being white. A lot of time these values are killed to a range between 0 and 1. This is called normalization. We can see that in the image we have on the screen. A 3D tensor is a stack of multiple 2D tensors on each other. If you take a close look at an image, it's made up of pixels, which are little points. These points normally have a color value. One way of representing those values is with 3 numbers called RGB values. RGB is essentially 3 channels. The same image has a red value, green value, and blue value. Same info, but distributed in 3 channels. If you need to pass a batch of images for processing, you'll make use of 4D tensor. To make things clearer, when you work in machine learning or deep learning, you'll find that it's not normal to deal with individual pieces of info. Rather, you submit info in batches. While an image is a 3D tensor, you'll need to submit your images for processing in the form of a 4D tensor. So you can have all sorts of tenses. You can have 5 tenses, and the number of dimensions can keep increasing. Let's look at some code in our notebook. On the screen right now, we have our notebook, and as usual, install TensorFlow. Once it's complete, we can go ahead and import TensorFlow, Keras, and NumPy. Let's look at a 1D tensor. We can create a 1D tensor from a NumPy array with only one coordinate. In this example, we create a NumPy array with 5 values in it. We can convert that into tensor with the TensorFlow operation tf.multiply. We could then print the outputs of that multiplication as well as inspect the shape. We could create a 2D tensor by creating a 2D NumPy array and carrying out TensorFlow operation on it. We can see from the output that our shape has 2 dimensions. We'll create a 3D tensor by downloading any image from the internet, then converting it into a tensor in this line. We fetch the file from the internet using keras.utils.getFile. We store the reference to this file in the variable file path. In the highlighted cell, we read our downloaded file using tf.io.readFile. This gives us the raw image. We'll go ahead and inspect the first 100 entries in the next highlighted cell. We convert our image to tensor using tf.image.decodeImage. This function will try to determine what type of image we have. This could be a JPEG, a bitmap, or PNG. It'll then produce an image tensor. We could go ahead and inspect the shape of our tensor, as well as the data types. You can see from the shape of our image, we have 428 pixels by 590. We also have 3 channels. That's represented of RGB color channels. You can also see that our data type is of unsigned integer. It means the values of those channels range from 0 to 255. In the highlighted cell, we proceed to resize our image into a square, a size of 192 pixels by 192. It's a frequency operation that you can expect to carry out when dealing with images. A lot of the time, the images might not come in squares, but you'll need to resize them into squares. You can also see where a division by 255 is done. And what that'll do is scale the values of the RGB channels from 0 to 1. By printing out the shape, we can see that we have a square image of 192 by 192 and 3 channels. We can also see that the min value is 0, the max value is 1. Essentially, the image has been scaled. Now, when dealing with tensor, there are a few things we might need to do. Slicing is one operation that we might need to carry out. When we have a matrix, we might need to get a subset of that matrix. For example, we had a tensor with 2 rows and 5 columns. In this instruction, we're printing out all the rows in the tensor, but only all the columns up to the 3rd, but excluding it. So we'll get rows 0 and 1, and columns 0, 1, and 2. We can see that we get a tensor of shape 2, 3, which is a subset of our initial tensor of shape 2, 5. Another operation we might need to carry out is reshaping. We used tf.reshape to get that done. In the first cell, we reshape everything. By using -1, what that does is it flattens the image completely on the tensor. So given any tensor or any n-dimensional tensor, you can flatten it out completely using -1. Of course, you'll need to know the original shapes, so they could go back to it. In the second cell, we used tf.reshape, but we reshaped into a 3D tensor. So what that means is we took our original 2D tensor with 2 rows and 5 columns and added an extra dimension to it. This essentially creates a 3D tensor and lets us pass a 2D tensor to a function that requires a 3D tensor. Now that you have a sense of data and tenses, let's proceed to build our first model in the next video.